All right, guys, I got a blast from the past vintage repair for you this time. This is a 1983 Commodore dot matrix printer that has a few problems, and I decided, I'm going to fix this and make a video of it. Might help somebody out. First thing we're going to look at is it has a power problem, right? So the power switch is over on the right-hand side here. I've got it plugged in with a known good AC power supply. And the LED light to tell you when the power is on is built into this button here. And when we turn the switch on, it just flashes one time. I'll turn it back off and again. So we've got some sort of a power supply problem to the logic board, so we're not getting plus 5 volts. I'm going to take the top cover off, and to do that, you can lift up the hood here. There's a couple of Phillips screws in the corners. Each corner there's one, and then in the very back of the printer, there's two more Phillips screws. So let me remove those and we'll come back. Got the cover off this old guy. And what you see is pretty typical for consumer electronics from 30 years ago in the early 80s. The power supply was what was called a linear power supply. So you have AC voltage coming in to a rather large transformer that's used to step it down. So in this case, it's 120 volts in. There's a tied-off red lead here. That'd probably most likely be for a European market instead of the US, where you'd get 220. And it comes into the other side where you have two secondaries that come out with different voltages. And based on the application here with the logic board and the various stepper motors for this printer, I'm going to guess that the lower voltage runs 9 to 10 volts AC. The outer voltage probably runs around 25 volts AC before it gets in to the next step. These things are going to come into this board. They're going to go through what's called a bridge rectifier, both of them, to convert them from alternating current to direct current, and then they're going to go through a series of filtering capacitors before they go to a voltage regulator. At least in the case of the board's power, which has got to be 5 volts DC. I suspect the AC power might even get passed straight through. We'll find out as we debug this. All right, so the first thing I'm going to do is verify that the transformer is okay. I kind of feel like the fuse and the switch are okay, or we wouldn't have gotten the LED in the front to flash. So let's go to the next step and power this guy on and take a look at what voltage we're getting. So I'm going to set my meter here for AC voltage. And what I've done, connect our power connector, get our power on. And again, you got to be careful here. You can get shocked very easily. So be very careful in this old gear, especially a big transformer like this. This cable goes into the lower part, and I've figured out that this is the connector that it corresponds to on the solder side. And the blue is on the secondary, is on the inner, the two inners, and the orange is a secondary on the two outers. So let's see what we get here. Taking a look at voltage on the inner two. And I see we're getting 9.5 volts AC. That's about what I thought, 9 to 10 volts AC. And then on the outer, we're getting 23.7. All right, so about 24 volts AC on the outer. So now we know this transformer works, which is a great thing because we'd never be able to find a replacement for this nowadays. So now we can work on the board. Without taking the board off and just looking on the other side, there's a couple of bridge rectifiers that I was mentioning, KBL-02 models that are going to convert us from AC to DC and stabilize the voltage in a number of filtering capacitors. I'm not even going to test these filtering capacitors. They're 30 years old. I'm just going to replace all of them. By this time, they're shot or below spec anyway. And I think I'm just going to go ahead and replace the two KBL-02 bridge rectifiers because they're cheap too. So let me go do that. I'm just going to go solder these guys out and replace them, and we'll come back and we'll see where we land at that after that. Guys, I've taken off this this board that was in the printer. We saw it sitting like this. And flip it over for a second. Those were the points that we were taking the voltage measurements. And what I've done is, like I said, I've gone in here and I've replaced the filtering capacitors. There's a couple here on the 24 volt side, and then there's the rest of these guys are coming in from the 9 volt side because these go bad, and there's just absolutely no point even messing around with them on something from 1983. And let me just say one thing about this. The capacitor that was used here was a 6800 microfarad capacitor at 35 volts. And back in 1983, it was something this size compared to something this size that you can get from Mauser today. But back then, the capacitors had 3 pins. And the reason for that is one of the pins was to help secure it to the board. You're not going to be able to find that today, and you don't need it. So when you go secure this guy, you don't care about this pin that was used for connecting to the board. Just make sure you get the right negative and positive. And again, as typical, even back in the 80s, the plus is going to be near the positive pin for these electrolytic capacitors. Now, just to show you a comparison, I did have a different size here. When you look at the schematic for this particular printer from Commodore, even though what we see from the manufacturing line in Japan back then was 35 volts, 6800 microfarads, the schematic called for a 50 volt. And if I look at a 50 volt modern capacitor, we see that the height is actually the same for a 50 volt 6800 microfarad, although it's much more narrower because technology has improved. But I went with a 35 volt the way the manufacturing line had it, not the way the schematic has it. Many times engineering will ask for a certain part, and then when things are being manufactured, particularly for the consumer electronics space, they'll be downsized and cost reduced, and it's always better to go with what you actually find on the board, as long as you can be fairly confident it wasn't replaced by some user. I know some user didn't replace a 3-pin capacitor. All right, so the next thing I replaced on here were these two bridge rectifiers we talked about, these two KBL02s. Just to show you what these look like out of being signed. They like this, right? They're pretty heavy duty guys. And again, they take the AC power in and convert it to DC. So with all that done, surprise, surprise, it still didn't work. But this was all good to do, right? Because these parts are ancient history, and they would have been a problem later on at some point. So this subassembly I think I'm done with, because I'm fairly confident, because the printer worked before it was put in storage for a few years. I'm fairly confident the rest of this logic board is probably okay. So now what we moved on to, there was a daughter board with some heat sinks and a couple of T03 parts. One of the parts that was on here I already replaced. And again, it was just, to be sure that it wasn't a problem. And it was one of these transistors over here, which is a power amplifier, a Toshiba 2SB554. And I've just put, a newer one on here, just in case. I actually tested this. It tested out okay, but again, it's from 1983. It's cheap. Why not? So the last thing left was the voltage regulator, which is most likely what it's going to be. I was going to try and just knock this repair out and show you where I got. And then I found out that even with that, we had a problem. The part that came off of here is kind of obscure. It's made from Sanken. It's an SI-3554M. I know it's a 5-volt regulator, and I tried to replace it with something comparable that's a 5-volt regulator. And the first thing I tried with that was with an SK9067. Which is just a standard 5-volt 3-amp regulator. I got a solid LED with this. This whole heatsink just got super hot, and I still didn't have 5 volts to the board. So that told me that it's more than just 5 volts, but I couldn't find a data sheet for this guy, and this is the main reason I'm making this video is because of this obscure information. So Sanken Electronics is still in business in Japan, and I contacted the company, and I found out that they share with me a data sheet for this guy from 1978 in Japanese, but I was able to get it translated. This is a 4-amp regulator, so that's why the other one didn't work. So what I ended up having to do is try to locate a couple of alternates that can do, there's nothing that you can get that's 4 amps, but there were a couple of 5-amp parts. One option for 5 amps is an LT1003, and another option for 5 amps, and this is the one I'm actually going to use for the repair, is a Philips ECG 932. And I'll tell you why I'm going to use this 932 rather than this other guy. There's so many Chinese fakes and knockoff parts out there that when I need something like this that has to be a real part that's 5 amps, I don't want to mess around with something that might be just a 3-amp part that's been remanufactured. And just not comfortable if this is the real thing. But let me show you how you test these guys before we put this guy on. I'm going to move this board out of the way here. I'm going to bring a power supply over. And what you're looking at on these old TO3 parts, I guess what first we'll do is we'll take the old part. Ground's going to be the outer casework. And then you want to look at the way these pins are, 1 and 2. They're kind of offset from the center. And the closer they are to the top is how you know which one's 1 and which one's 2, right? So we can see there's bigger distance from here to here than there is from here to here. So this is the top And sometimes you'll actually see them stamped 1 and 2. The power input from the power supply is going to go on this input pin. This is our input voltage. And then what I'm going to do is I'm going to take my meter here off screen for a second. I'm going to change out my meter leads from probes to clamps. And then I'm going to take my meter, put it on the ground here as well, and then I'm going to put it on the output pin. And you just want to make sure these guys are not touching the case because, like I mentioned, that is the ground. We're going to put this guy on volts, DC volts, and we're going to turn on the power. And I'm going to put in 10 volts DC on this power supply. I don't know if you can see this. This guy doesn't light up in the back, but we got 10 volts in, and what we see coming out is 0.6 DC. So it's a bad part. We kind of already knew that, but we just confirmed it. So now we're going to disconnect all this. Again, this was the original one, the SI-3554M. And let's take a look at our LT1003 part. Same deal, ground on the case. Take our meter lead and put on the output. And take our power supply lead and put on the input. And just make sure that nothing's touching. Take a look at our meter. We're going to give power again. And voila! We got 10 volts in, and we're getting 4.85 volts out. So we know this is a working voltage regulator. Disconnect these guys again. Let's check the other part, the one I actually plan on using because I just feel more comfortable with it. The ECG932 from Philips. And again, this is a really great design on Philips. It's another reason why I feel this is our authentic vintage part. It's kind of like a, like a half hourglass shape here to help show you which is top and bottom. The smaller is the top, the larger indentation is the bottom. Come over here and put our ground leads rather. Take my meter on the number 2 pin for the output. Take my power supply on the input. And we don't want to run these things too long without a heat sink because they can get hot even with no real strong load. All right, we'll put some power on this guy. Bam, 5.06 volts with 10 volts in. Even better than the other one, and this is the one I wanted, so this is the part I like. We're going to go with this. But this, I just thought I'd show you how you go about testing some of these old T03 type case voltage regulators from the 1970s and the 1980s. All right, we're going to mount this guy on a plastic insulator, and then we're going to, and you can see by the way on the cutout, right? You see how the small holes are closer to the top than the bottom? It's really next to impossible to screw up lining one of these things up properly because they're only going to go in one way. And in this particular case, they've got some little insulators that they came with. And I'm going to go ahead and fasten the lower retaining bolt just to make it easier to do the soldering that I need to do here. And just in case something moves around and makes contact with the heat sink, Commodore had a couple of little tiny pieces of heat shrink tubing that I took off the old one. I'm just going to reuse that, slide it over these pins on the replacement. Right, and then what we're going to do is we're going to resolder these lines that we took off on the other side. So. And then what will happen up here, I'll go ahead and do that with this top retaining bolt, is that there's a lead that goes under the nut for this connector. And we'll just go ahead and do that. So I'm not going to necessarily, film resoldering this. I'm going to tighten this up, resolder it, get it all put back in the printer board, and let's see what we got. Come back in a few minutes. This guy back in. Going to just go through the reattachment just in case you might have forgot how things go when you took yours apart. I'm attaching this ground wire from the logic board to the main chassis first, and then I'm going to replace the side mounting screws. Going to give it a little bit of support before I start trying to plug in the various cables. go into it. Not necessarily going to plug them all in here and burn up too much video, but I think just securing this will be enough. All right, so now we come up here. First guy you have is this kind of dark one, black and gray. It goes right in here. And the next one, the one with the wire, no wire, and then 2 wires. He goes on the outer side. The middle one's a skip. And then you have a wire, no wire, a wire, and 2 blanks. That goes here. And this black one goes in the middle. And this white one goes here. I'm talking about the color of the connectors, of course. All right, and then this is our transformer wire. We started this out with measuring. He goes all the way on the bottom down here, like I mentioned before. Snap him in. And then we've got this small daughter board that we were working on, which actually held the voltage regulator. I'm going to slide him in here. And we're going to get 1 screw in him so that we have some support so that we can then attach the remaining 2 leads. Actually, we'll go ahead and put the other one in. Alright guys, sorry about that little bleep. Little interruption was because the camera had a glitch and ran out of space. I had to delete a file to continue this. Alright, so I'm just snugging these guys down on this, this small heatsink board where we have our power amplifier and our voltage regulator. And then we've got a couple of screws over on the side here to complete the mount. One more. All the way in the back. All right, so we've got 2 brand new bridge rectifiers. We've got, by the way, yeah, the power amp goes into the top part, and then our voltage regulator goes into, there's a little 3-way. You'll see it, I can't really get the camera down here, but because it's obscured by one of these capacitors. But it's right here, a little 3-way pin. You can only put it in one way, so there's no way to screw it up. All right, so again, new power amplifier. Probably didn't need that one, so that was optional. New electrolytic filtering capacitors. Definitely have to do that with something 30 years old like this. A couple of new bridge rectifiers. Probably could have skipped that, but why not? We're in there. They're cheap. I hook the power back up here. And then the most important part, and the part that was primarily responsible for the failure, that obscure voltage regulator, and replaced that 5-volt 4-amp regulator with a 5-volt 5-amp regulator from Philips. All right, let's power this guy on and see what happens. I hear some noise, but I don't see an LED still. So what we're going to have to do is get out the meter and keep debugging. So let's keep going. It's the fun part of doing this stuff. This turned out to be not so bad. So you remember earlier in the video I mentioned I had wrote to Sanken and gotten a copy of this Japanese data sheet for this particular voltage regulator, the SI-3554M. You know, when I first got this, what I was preoccupied with, you know, it's all in Japanese, of course, I was preoccupied with the specifications, right? And so even though this is all in Japanese, you can see that these are voltage readouts. And what I was mostly after was that I needed to have a particular amperage level. And I used the part that we ended up going with, the ECG 932, to match that. But as we found out when it didn't work, I started to realize something, and what I realized is I kind of thought back, and I'll go back and annotate this video so that it's clear to you guys. But you know, when I come in here and I look at what we've got, let me get the light over here, what we've got here with this power transistor, we can see that the ground wire is brown, and then we have a blue and an orange. And I've corrected it now, but if you guys look back earlier in the video, you'll notice this brown and this blue were reversed. And the reason for that is in the data sheet. So if we come back and look at the data sheet, and we take a look, for example, at the CG-932, we see typically what we expect on this type of package. Pin 1 for an input, pin 2 for an output, and case being the ground. And if we take a look at this SI-3554, and we go through here, we don't necessarily see a same type of information, but we can find a drawing here, and it shows pin 1 and 2, but they actually are backwards. That's not really the main problem, though. So they're showing 2 on the left and 1 on the right versus 1 and 2. But if you scroll back a bit, then you notice the problem. So I happen to first notice it on this internal diagram. This is an internal diagram or schematic of what's inside the voltage regulator in terms of its layout of transistors and diodes, resistors, and such. And here we see pin 1, pin 2, and pin 3. But what really drew my attention to this was the sample circuit. I usually always find one of these. Let's stay here for a second. And let's take a look at the sample circuit in the 932, the CG-932, for comparison. And this is what really caused me to realize that was what the problem was. So in the sample circuit here, I've got pin 3 is obviously my case, my ground. I got that as common. Pin 2 is my output. Pin 1 is my input, right? It's what you'd expect on this type of packaging. But on this Japanese part, it's a little different. They've actually got pin 1 as the positive output, pin 2 as the negative output, and the case, the actual case, is the input. And that's why Commodore originally had that power supply wired differently than that standard Toshiba power transformer. So once I went in here and swapped that blue and gray wire to match what we would expect with a more typical industry standard part like this from what was on this Sanken part, well, now if we step back and watch this on the front here on this LED, or actually watch the print head and everything, I'm going to turn it back on. There's a little bit of a lag when you first turn it on. Then the thing comes on, and the guy works just fine. So it was a good repair, and it was an extra little tip here to watch on things like this. Sometimes in these old parts, something obscure is wired a little bit differently. But we've got this guy back in service. He's working fine now, and I hope this video helps you out for debugging your own parts. If you have any questions, put it in the comments. Otherwise, like and subscribe. Thanks for watching.